For a novice, for a person who's given a business scenario, and or for instance, let us put it in the perspective of an interview question itself. You are given a business scenario. You have this data. You have data which is having a mixture of categorical and continuous values. The output is discrete. The output is discrete in multiple categories. I propose to use decision tree. And I propose to use some other, classification algorithm. Let us say a k-nearest neighbor classification algorithm. Given this much information, which do you think would be better? Which model would give me better results? How would you answer such a question? I'm not getting into the details of the variables and all that, but yeah, you can probably assume something. And the point I'm trying to make here is that the knowledge of or the requirement of explainability has not been mentioned. So how can we, take this to the next level?
All right. So one specific point that you mentioned, which caught my attention, is you have mixed input factors, mixed data. And this is something that captured my attention.
Yes.
Now, when we try to predict the target variable, which is you're saying is a discrete value.
Multi-class. Let me correct. Multi-class, not binary, but multi-class. Yeah.
Done. So discrete, but it is discrete, right? So multi-class. Yeah. Now, when you have this kind of a scenario, to be frank, we don't have predefined rules to say that you have to use decision tree or you have to use KNN or you have to use Knight-based algorithm. We generally try and apply each of these algorithms and see which one is behaving better. Now, when we try to apply decision tree, because we are focusing on our this particular session on decision trees, I'll throw more light on that. I'll be focusing on that. When I want to use decision tree, one of the important prerequisite point that you need to remember is that your input factors that you're using should always be discrete in nature. They cannot be continuous in nature. Because the decision tree is trying to split your data, right? Divide and conquer manner. It is trying to split the data to generate homogeneous branches. Now, when you are trying to create branches, we basically take an input factor, and based on this particular factor, we create the branches on the conditions that the input factor has. But can I have an infinite branches? I cannot have infinite number of branches. Hence, the requirement is that your input factor should be discrete. If you have continuous data, obviously you will have to do those manipulations. For every algorithm, you'll have certain conditions. In decision tree, we need to ensure that we discretize the data. So if you have a continuous data, you try to break that up into groups and use that as your input. So that is one of the points that we use. I mean, that's the way decision tree is applied. And once you get the results, you will try to see the rules that are getting generated. The Python libraries will allow us to also visualize the entire tree and then see what is the flow of the data and how a rule is created. And in decision tree, we generally say the path, the flow from the first node, we call this as root node, till the leaf node. So it's like your flow chart where we are trying to follow the flow based on the conditions and reach the last node. And when you see the last node, you should be able to define the categories belonging to that particular node. You should be able to define, right? So saying that this branch belongs to this category. So if you can do that, then this is our branch, or this is our rule. This path is our rule. And this allows us to explain our output. So this is the interpretability that we will be preferring with respect to decision trees over the other algorithms that we see.
Thank you. Thank you so much, Sharath.